All right, this is the answer key to exercise set 3.2. Use the fundamental theorem of calculus to evaluate each integral expression. So, um, first one. So, the way that I think about this is one thing at a time, like kind of working my way, I guess, from the inside out. And I kind of think I see the integral, I want to deal with the integral, and then I'll think about taking the derivative. So here, let's call, I'm going to write it in kind of basic terms. So I'm not necessarily, well, for the first one, I'll do the full integral for this one. So it's going to be, when I take the antiderivative of this, so ignore the ddx for now, take the antiderivative of this, we're going to get t, 3t squared over 2 minus 5 t uh, plus c um, from 3 to x, right? Um, which is the antiderivative at x minus the antiderivative at 3. So, and so now I'm going to bring that ddx back. So I'm taking the derivative of this whole thing. So look at the first one. The derivative of the antiderivative of x is our original function, 3x minus 5. Okay, think about that. This is the antiderivative, right? F of x. If we think about f of x, big F of x equals 3x squared over 2 minus 5x plus c. Therefore, little f of x is going to be 3x minus 5. Okay, so the derivative of this is this, and that's what I did there. I took the derivative of this. Next one, if you think about the antiderivative at 3, that means I plug 3 into this, right? And I get some number, correct? I take the derivative of that some number. Remember, derivative of constant is 0. So this is just 3x minus 5. Okay, next one. So again, let's work from the inside out. Let's take the derivative of this, right? The derivative of this is 3, right? So this is really saying integral 3 to x of 3 dt. Okay, let's do it. So we're going to take the antiderivative. We're going to get 3 t plus c from 3 to x. Okay, plug in the x. We're going to get 3x plus c minus, plug in the 3, 9 plus c. Answer 3x minus 9. The c's cancel. The answer is 3x minus 9. Okay? So, I think there's this idea, and I think I misrepresented this, that these just always just cancel each other, and you just have the inside. This is just what you have. But that's not true. You do have to, sometimes that's true. When you do indefinite integrals, which we have an indefinite integral coming up, that is essentially what happens. They just undo each other. But when you have a definite integral, you do have to apply the fundamental theorem of calculus part 2. So in this one, so this is an interesting one. It's the derivative of this integral from 3 to 5. Okay. So in this case, I don't need to go and do, I don't necessarily need to go and do everything. It's the same as this one up here. So it's a derivative. Okay, well, I will do it. This is 3x squared over 2 minus 5x plus c from 3 to 5. But it's the derivative of all this. Okay, so if I did fundamental theorem of calculus, it's going to be the derivative of f of 5 minus f of 3. You agree with me? Right? So I just did fundamental theorem of calculus part 2 on this. And I'm going to apply fundamental theorem of calculus part 1 now, kind of. So again, you plug in a 5 into this. You plug in a 3 into this. You're going to get numbers. The derivative of a number is 0. This is 0 minus 0. The answer is 0. This is more just derivative rules and less fundamental theorem of calculus. You're taking the derivative of two output values. You're going to get zeros because these are just numbers. Okay, for this one, we have the derivative, integral derivative, indefinite. So let's take the derivative. The derivative of this is, let's do what's inside the parentheses. The derivative of this is 3. We're taking the integral of 3 dx. You see that? Right? You agree with me, right? The derivative of 3x minus 5 is 3. Right? So now we're taking the integral of 3. Well, what's the integral of 3? Well, the integral of 3 is 3x plus c. Okay? So yes, they undo each other. And you're going to see that really done here, though. This is where you're really going to see them undo each other. So the integral of cosine x squared is going to be sine, right? However, now this is where they truly undo each other. The derivative of the integral is simply that original function. This is cosine x squared. Okay, this is where they undo each other. See the difference? This one, I had to differentiate it, and then I took the integral, and you have 3x plus c. And in this one, because they're switched, the places are switched, this is fundamental theorem of calculus part 1. Let me see if I have the notes on me. Yes, here we are. So this is what fundamental theorem of calculus says, is that the derivative of from a to x of f of t to t is equal to f of x. So right here, that's what we're saying. The derivative of the integral equals the original. Okay. And then this one, so this one, again, so you would be taking the derivative. So imagine, let's just pretend for a second that instead of d dx cosine x squared, that this is my derivative here, and my original function is just cosine x squared. Okay. And this is the derivative. So I'm saying take the integral 1 to 4 of the derivative dx. Well, what's the antiderivative of this? Well, it's just f of x. Okay. This is fundamental theorem of calculus in action here. That the derivative, the integral of a derivative is the original. Okay. From 1 to 4, and then I'll do f of 4 minus f of 1. So it's going to be cosine 16 minus cosine 1. You can leave it like that. So yeah, key here, I mean, these are really just the steps of the fundamental theorem of calculus in action, but instead of writing an f of x and a capital F of x, I'm writing the derivative and then the original. So anyway, this is the final answer. All right, back to, in a way, this side is more straightforward because you're not dealing with any derivatives. It's only integrals. So evaluate the integrals, fundamental theorem of calculus. It's just a lot of the same. This one, so first antiderivative of this, we're going to subtract 1. So add 1 and divide, right? So it's going to be over -2. So it's going to be negative x to the negative second, 8 to 1, or 1 to 8 rather. And then, so it's going to be, antiderivative 8 minus antiderivative 1. So it's going to be negative 1 over 8 squared minus negative 1 over 1 squared. So that should come out to 63 over 64. Basically, this is like positive 1 right here because you got a double negative, and it's 1 over 1. This is just 1. So this is just like, this is a plus 1, right? You agree with that? And then this is negative 1 over 64 plus 1. So what's left over? You have a whole minus 1/64th is 63 over 64. Okay. Next one, sine x, integral pi over 4 to pi over 2. So first, we can take the antiderivative of what is sine x. And again, you can like Google this if you need to, right? You don't need a, we're not quite at the stage of memorizing this yet. The integral is negative cosine x. So we have negative cosine x from pi over 4 to pi over 2. So we're going to have, again, like f of antiderivative at pi over 2 minus antiderivative at pi over 4. So pi over 2 cosine pi over 2 is 0. So that's just 0. Minus pi over 4 is root 2 over 2. So minus, but it's a negative, negative cosine of this, negative cosine of that. So it's going to be negative root, double negative root 2 over 2. So our answer is going to be just, this should be root 2 over 2. Okay. Next one, 3 root x from 4 to 9. So with the root x, we got to convert it. I can't take the integral of this in its current form. So I'm going to write here, I'm going to show you the conversion. 4 to 9, 3, and then instead of root x, x to the 1/2. Now I can do my antiderivative. I'm also going to move that 3 to the front to make it easier. Like in general, that's a great rule. It's just taking out any common factors and moving into front is just a good idea. And now let's take the interior. So if the 3 is going to come out, I can move the 3 away. So now final is integral 4 to 9, which is x to 1/2. Power rule on this thing, inverse power rule. So add 1, divide by that value. We're going to get x to the 3/2 over 3/2. So when you end up dividing by a fraction like this, this is the same as multiplying by the reciprocal of that fraction. So this is 2x to the 3/2 over 3. See this 3/2, I flipped them to be 2/3. Okay. This is my antiderivative from 4 to 9. So then we'll do f of 9 minus f of 4. Plug in a 9, plug in a 4, and you should get 38 is your answer. Okay. That is C. D. Integral 0 to 2, 3x squared minus 6x plus 2. So same thing. Also, guys, I'm getting sloppy. But there is a plus C in all these. Plus C and a plus C and a plus C. So do not forget that. Okay. Here. Integral. This is going to be x cubed plus 1 divided by 3 minus plus 1 divided by 2. So it's x squared over 3x squared plus 2x plus c, 0 to 2. plug it in. So we're going to get f of 2 minus f of 0. We already know that that's going to be 0. And when you plug in a 2, you actually also get 0. So you get 0 minus 0, which is 0. Okay. This one, similar to C in a way. I can't deal with this in the denominator. Got to move it. And that 2 is already in front. Just a heads up, sorry, on C, don't forget to multiply this value by 3. So when you multiplied it by 3, you would get 38. That's how that's 38. Okay. For 2, don't forget this 2 out in front. We still have to multiply by 2 at the end, but we're going to move that integral up to be 3x to the negative second. I can move that 3 out in front to become a 6 out front. Integral 1 to 3x to the negative second. Add 1, divide by that value, so we get x to the negative first divided by negative 1, so it's going to be a negative x to the negative first plus c from 1 to 3, f of 3 minus f of 1. Plug in the 3, so that's negative 1 over 3 plus the c, right, minus negative 1 over 1 plus the c. So we have, this is 2/3. So it's going to be a positive 1, so it's a 2/3. But then we multiply it by that 6 from before, so you should get 4. Okay. Well, we got 3 more here. Negative 1 to 8, x to 1/3. So this is already in a situation where we can deal with it. Add 1, divide by it. So 1/3 plus 3/3 equals 4/3. So we're going to have integral negative 1 to 8 x to the 4/3 over, forget this, 4/3 over 4/3. So remember what I said, when you divide by a fraction, you flip the fraction, you multiply. So it's 3x to the 4/3 over 4 plus c negative 1 to 8. And then f of 8, you're just plugging in at this point, minus f of negative 1. You should get 11.25. I'm not going to do the math. It's 11.25. Okay. This one, just kind of a longer one, but same process. You are going to find the integer. So it's 2 separate integrals. So first you take the integer of this one, you're going to get x squared minus 20x plus c from 3 to 9. That's 1. And then you got another one where it's going to be x squared over 2 minus 10x plus c from negative 2 to 3. We're going to multiply that one by 2. Okay. So it's 2 times that one, it's 1 times that one. So you have, for the first one, let's call this one like kind of f of x. Let's call this one g of x. So it would be f of 9 minus f of 3. And then you're going to add 2 times whatever this is, g of 3 minus g of negative 2. And when you do that, you should get negative 143. Okay, so do this. Do the calculating by yourself. Okay, you can check your work. This one, just a messy fraction, just messy. This is a messy integral. There's nothing much else to say about it. We're going to add 1 and divide by that value. So negative 2/3 plus 3/3 is 1/3. So this is going to turn into 9m to the 1/3 divided by a third. We'll talk about that in a second. Minus, this is going to be -2. I'll just write it out. This is going to be minus 2m to the -2 over -2. Okay, so remember, when you divide by a fraction, it flips, so it's going to be 27 m. It's going to be over 1, so it's fine. M to the 1/3. And then these two will cancel, plus m to the -2 plus the c from 1 to 27. F of 27 minus f of 1 gets you about roughly 53. And that's it. Okay, so that's exercise set 3.2. So my advice, careful with these. Sometimes it's easy and sometimes it's not. Just take your time with them, write out really what's going on to be careful. Okay. This is the standard one that you're going to see a lot. This one's kind of tricky, can trick you. This one can also trick you. The fact that this is 0. So be careful.